Today we are going to go over 8.9 part 1, Geometric Power Series. In 8.8 we learned power series. So for the power series, any series in the form A1 plus A2 R plus A3 R squared plus etc. So this form we call it power series. For geometric series, because we have common ratio, it's a little bit special. The geometric series is a series something like A is a coefficient, the first term, plus A times R plus A times R squared plus AR cubed. So the ratio between each two consecutive terms, which we call the common ratio, and the first time is A. For geometric series to converge, as we know, the absolute value of R has to be less than 1. So R has to be between -1 and 1. If R is between -1 and 1, the formula for the sum will be A, the first term, over 1 minus R. So now, because this is the sum, that means sigma n equals 0 to infinity A R times n will be A over 1 minus R if R is between -1 and 1. So today we are going to go from the right side to the left. Given any fractions, how do we write a fraction as a power series, geometric power series? So our goal is trying to match this sum and then figure out what is A, what is R. That's it, for example. So let's have a look at this one. Given f of x equals 1 over 2x, center equals 0, how do we write a geometric series at center equals 0? So if you look at this form, we compare this with A over 1 minus R. That means A will be 1 and R equals 2x. And you see this 2x, x minus c, so c is 0. That's good. So f of x equals 1 over 1 minus 2x will be sigma n from 0 to 1. A times R to the n, A times R to the n. A in this case is 1, R is 2x to the n. So which is sigma 2 to the n times x to the n. And of course, in order to make sure it's convergent, so the R common ratio has to be less than 1. Give us x less than 1/2. So the radius of convergence will be 1/2, and the interval convergence -1/2 to 1/2. So the good thing is you don't have to check endpoints. R cannot be 1, so the boundary is always going to be open for geometric series. Let's have a look at another example. So given fx equals this, we want to write this as a geometric series, power series, centered at 2. So because centered at 2, so we have to have x minus 2 in our form. So what we do first, we are going to have a look at the denominator. We only have x here. We are going to change this x with minus 2 plus 2 here. You see, now we have x minus 2 now. So this will be 5 over 6 plus x minus 2. We compare this with A over 1 minus R. This number has to be 1. So we are going to divide everything by 6, numerator and denominator by 6. 5 over 6 over 1 plus x minus 2 over 6. You see, now we change this form into A divided by 1 minus R. So this case A equals 5 over 6. And R, be careful, R will be negative x minus 2 over 6. So after we figured out A, so f of x will be sigma, n goes from 0 to infinity, A times R to the n power. So -1 to the n, we can write it out. 5 over 6 times 6 to the x minus 2 to the n, 6 to the n power. And of course, you can combine everything together. This will give you don't have to. negative 1 to the n, 5, x minus 2 to the nth power over 6 to the n plus 1. You see, the reason why we write it as x minus x plus 2 here, because we want to make sure we have x minus c, this form. Now let's deal with the radius of convergence and interval convergence. The radius of convergence, we have to change x minus c less than r. We have to say x minus 2 in this case less than what? So as we know, absolute value of r is less than 1. So we put absolute value of r here. That means x minus 2 is less than 6. So the radius of convergence equals 6. And the interval convergence, we just solve this inequality, negative 4 to 8. So radius of convergence is 6, and interval of convergence, which will be negative 4 to 8. Now let's have a look at another example. This example is a little bit more complicated. So if you look at the first two examples, all the denominator is only it's a line. Basically, we only have x to the first power. This one, we have x squared, so we have to factor this one first. So f of x equals 6x over x squared plus 2x minus 8, which is 6x over x plus 4, x minus 2. So now we are going to split this into two functions. Now we can solve for a, b. So 6 of x equals a times x minus 2 plus b times x plus 4. Now we set x equals 2 and x equals negative 4, give us b equals 2 and a equals 4. So now we can express f of x using 4 over x plus 4 plus 2 over x minus 2. Now this looks like what we have so far. So now we have to look at compare with a over 1 minus r. You can change this to 4 over 4 plus x plus 2 over negative 2 plus x. We divide by 4 for the first one, so it's 1 over 1 plus x over 4. Second one, you want to change it to 1, so we can divide everything by negative 2. So it's negative 1 over 1 minus x over 2. So this one give us a equals 1, r equals negative x over 4. This one, a equals negative 1, r equals x over 2. So this will be sigma n equals 0 to infinity a1 times r to the n plus second one a1 negative 1 times x over 2 to the nth power. Okay, of course you can combine everything together. You don't have to simplify it. You can leave your answer like this, or you can combine them. It's power negative 1. However, when we deal with the radius of convergence for the first one, so negative x over 4 less than 1. For the second one, x over 2 less than 1. So this gives us x less than 4. This is x less than 2. Because center is 0, that looks nice. However, we have to make sure both of them converge. So we have to find the common part. Okay, so let's have a look. This one is from negative 4 to 4. The second one is from negative 2 to 2. So the common part will be from negative 2 to 2. So our radius of convergence will be r equals 2, and the interval of convergence will be negative 2 to positive 2. You guys have a look at this practice problem and try to solve it yourself and compare with my answer key. This is the answer key for this problem. Center at equals 0 and center equals 1. So center equals 1, so it's x minus 1 plus 1 here. Be careful, you have to have x minus 1 here.